Hey calculus kids, this is Dr. Callahan. Happy Monday, week 10. Go ahead and pause the video and answer the following 3 questions. Now, the last time I saw you guys, we went ahead and turned in the warm-up log. If you have not done that yet, make sure you turn to the second to last page of your warm-up log. There you will see a table, and I want you to fill out the number of boxes you've completed, what you think you should deserve out of 100 points for participation, what do you think you deserve out of 100 points for preparation, and your total should be out of 300. So make sure you turn to the second to last page of your warm-up log packet and take a look at that table and fill it out. So if I saw you on Friday, you already have the new warm-up log. If I did not see you on Friday, you need to turn that in on Monday and then grab the new warm-up log. So for now, you can do this on a separate piece of paper and then staple it to the new warm-up log when you guys get it. All right, you guys, let's go ahead and take a look at this. So I am going to go ahead and go over this question here from your warm-up log. So looking at this right here, you can see this as, say, let's let u be x, y. Then f prime, or excuse me, then f is going to be x, and then f prime is 1, g is y, g prime is 1, but then you're going to have a dy over dx, okay, because of the implicit differentiation. So the u prime is going to be the product rule of that, so that's going to be f prime times g, so that's 1 times y, which is y, plus f times g prime, so that's x, dy over dx. So then if I go ahead and put that as ln u plus 2x equals 14, let's go ahead and find the derivative of that. So the derivative of ln u is going to be 1 over u times u prime, which is going to be, if I replace it, it's 1 over u, and as you guys can see, u is xy, times u prime, so don't forget the parenthesis around the whole thing, y plus x dy over dx plus derivative 2x is just 2 equal to 0. All right, so then at this point, remember you want to get the dy over dx by itself. Anything that is not dy over dx, you want to stay on the left side, or I'm sorry, on the right side, you want to keep dy over dx on the left side. Now, you don't want to necessarily, distribute this, although you can if you want, but given the fact that the dy over dx is by itself right here, let's try to get rid of the 1 over xy because it doesn't have a dy over dx. So to get rid of that, you're going to multiply by xy on both sides. And actually, you know what? Because we have a 2 right here, that would technically screw it up. So let's try it this way. Let's go ahead and subtract the 2 on both sides. You have 1 over xy. Okay. Plus x dy over dx equals -2. Now to get rid of that, I'm going to multiply the xy on both sides. So times by xy on the left side, times by xy on the right side. And the reason why we don't want to do that is because if I were to multiply xy here, I would have to distribute the 2. And so that would have been like a little bit more frustrating. So then this part cancels. You have y plus x dy over dx equals -2xy. I mean, ultimately, you'll have the same steps. I mean, at this point, it doesn't really matter which one you decide to do. As long as what you're doing is legally algebraically, it's fine. Subtract the y on both sides. You have x dy over dx equals -2xy minus y. And then to get rid of this x, because I'm solving for dy over dx, I am going to divide it, everything by x. Here we go. So then I have dy over dx equals -2xy minus y over x. And that is my answer. Now, if you were to rewrite it, you could have a negative y factored out. So you have 2x plus 1 over x. And that is your answer. With implicit differentiation, with a u substitution, and then also with a transcendental derivative for the ln. All right, so let's go ahead and move on to today's stuff. So yes, last time I saw you guys, we talked about implicit differentiation for the first day. I showed you guys some of the free response questions you might have and how you're supposed to be answered on the AP exam. So make sure you guys check that out because you do have a link to see the answers. Today, this is kind of what we're going to be looking at. We're going to look at derivatives using implicit differentiation for day 2. I have a few things for you guys to work on in class with the station rotation and then also the calculus puzzle. Why was the math teacher forbidden to show a movie? We actually started this last time, but we didn't have time to finish it, so we will keep going with that. And then I have a dead or alive A question on implicit differentiation. So with that said, let's go ahead and jump right in. So for today, you guys should have the following available to you. So first things first, let's take a look at the breakdown. You should have this page right here, which is just practice question with the steps. I will probably try to put a paper over the answers first and just cover it so you don't see it. Try the questions on your own and see if you're able to do it by yourself. If you're not, then take a look at the steps. But you have a question, so that's first question. Then you have the second question right over here. So there's 8 altogether. Then, if you have time, go ahead and work on the calculus puzzle with why was the math teacher forbidden to show a movie about calculus. You have the questions of 1, 2, 3, 4 right here, 5, 6, 7, 8, 9, 10, 11, 12. So 12 questions. The answers are shown to you. So give that a try. And then I have a few additional questions right here that's also on implicit differentiation from the textbook along with the steps that's included. So make sure you give those a try as well. And then in class today, I'm going to go over these 2 questions right here. They're a little bit more complicated. It's implicit differentiation with vertical, horizontal tangent lines. So we'll go over those 2 questions. And then if you need to have a little bit more assistance, I do have a really good video here that's going to be on the 8 examples that you actually did see in class. So you can follow along with that. And that's kind of like the breakdown. So with that said, let's go ahead and get started with some of these more difficult questions right here. So go ahead and read the question and we'll go ahead and get going. All right, so number 57. Number 57 is asking you to go ahead and find the horizontal tangent line by setting the numerator of the derivative equal to 0 and solve for x. And you can find the vertical tangent line by setting the denominator of the derivative to equal to 0 and solve for x. And that makes sense because if you think about the horizontal tangent line, generally it's basically saying it's a horizontal tangent or a horizontal slope. If you look at the slope right here, the slope is equal to 0. So you have a 0 over some form of a number, but the numerator remains 0. So therefore you have to set the numerator to 0. Now on the other side, the way I remember this is that if it's a vertical tangent line, I think of it as a vertical slope. So it goes up and down. So in order for you to have a vertical slope, your slope is undefined. And you get the undefined because there's a 0 in the denominator right here. So that's why you want to set the denominator of the derivative to 0 for x. So that is the rule of how you go about doing that. Okay, so first thing we're going to do is we're going to go ahead and apply the implicit differentiation for this equation. So that will give me the derivative of 25x squared. So power rule gives me 50x plus, here's a y, 16 times 2 is a 32y, but then don't forget your dy over dx. Derivative of 200x is just 200. Derivative of negative 160y is negative 160 dy over dx. Derivative of 400 is just 0, and so derivative of 0 is still 0. So that's what you will have. Next, I'm going to go ahead and try to solve for my dy over dx. So I am going to move a few things around. Anything that doesn't have a dy over dx, like the 50x, I'm going to move it over to the right side. The 200 will be moved over to the right side. So it'll be a negative 200. And then what remains here is that you have the dy over dx, I'm going to factor that out. So dy over dx, what stays inside the parenthesis is a 32y minus 160. And then I'm going to divide everything so I can get the dy over dx by itself. So equal to negative 50x minus 200 divided by 32y minus 160. So now that I've solved for the slope, this is what I have after implicit differentiation. So let's go ahead and proceed with finding the vertical slope or vertical tangent line. So to find the vertical tangent line, I am going to take the denominator, which is this part right here, and set it equal to 0, and then solve for y. So I have 32y minus 160 is equal to 0. And so then I'm going to add the 160. So 32y equals 160 divided by 32. 160 divided by 32 is going to give you a 5. So then what you're going to do right here at this point is you are going to take the original derivative or the original functions right here in the implicit form, and you're going to replace y with 5. So then I have a 25x squared plus 32 times 5. Oh, I'm sorry, hold on a second. I'm getting the two confused. I'm looking at the first derivative. Plus 16 times 5 squared plus 200x minus 160 times 5 plus 400 equals 0. So grab your calculator and simplify that out. And you will be able to see that you're going to get a 25. Oops, running a little bit out of space here. 25 plus 5 times 5 is 25. 25 times 16 is going to give you a 400. Running out of space, but that's okay. Plus 200x minus 160 times 5 is going to be 800. Come on, just write it. Oh my goodness, it doesn't want to write. There we go. 800 and then plus 400. Okay, so let's go ahead and combine the like terms. So maybe I'll get a little bit more room over here. So then I'm going to have a 25x squared plus 200x equals 0. So then what you're going to do here is you want to solve for x. So what that means is that I'm going to go ahead and factor out a 25x. And what remains inside the parenthesis is an x plus 8 equals 0. So two answers, x equals 0 and x equals negative 8. So then if you're looking for the vertical tangent, okay, your vertical tangent means that your x is going to be 0. You got to find y. X is going to be negative 8. You got to find y. Okay, so how do you go about doing that is you're going to use the second calc option. You are going to plug in the value at 0 and figure out what y is. So you can go ahead and do that by plugging into the original equation and then solving for y. You should be able to find that y is going to give you a 5 when x is 0, and then y is going to give you a positive 5 when x is negative 8, and that is your vertical tangent. All right, so now that we did that, let's go ahead and find the horizontal tangent. So I'm going to go ahead and draw a little bit of a line here so that way we know the difference. There's a little bit of space in between. Okay, so to find the horizontal tangent, with this one, I'm going to take the numerator and set it equal to 0. So I have a negative 50x minus 200 equals 0. We're going to go ahead and solve for x. So then negative 50x equals positive 200. 200 divided by negative 50 is going to give me an x equals negative 4. Now, when you have x equals negative 4, you're going to plug that back into the original equation, but you're going to replace every x with a negative 4. So I have a 25 times negative 4 squared plus 16y squared plus 200 times negative 4 minus 160y plus 400 equals 0. Let's go ahead and simplify this. That is going to give you a 400 because negative 4 times 4 is 16. 16 times 25 is 400 plus 16y squared. Negative 4 times 200 is a negative 800 minus 160y plus 400 equals 0. You are going to go ahead and combine like terms. 400 minus 800 plus 400 is going to give you a 0. So what remains is 16y squared minus 160y equals 0. Now I can factor out a 16 and a y, and what remains inside is a y minus 10 equals 0. So when I solve for y equals 0 and y equals 10. All right, so now that I have this, let's go ahead and plug in for your vertical or horizontal tangent. So your horizontal tangent is going to figure out what is x when y is 0 and what is x when y is 10. And when you guys plug those numbers in here back into the original equation, you should have that it is going to be a negative 4, 0, and it's going to be a negative 4, 10. So these two are your answers for the horizontal tangent and the vertical tangent. All right, let's do one more example so that way you have a better idea of how to do this. So let's take a look at number 58. So first thing to do is going to find the implicit differentiation of this. So we are going to have the derivative of 4x squared, which is going to give you an 8x, 2y, but don't forget your dy over dx, minus 8 plus 4 dy over dx plus 0 equals 0. Then you're going to move anything that doesn't have a dy over dx over to the right side. So that gives you a negative 8x. That gives you a positive 8. If I factor out the dy over dx, what remains inside the parenthesis is going to be a 2y plus 4. So then when I divide it by 2y plus 4, I will have a negative 8x plus 8 divided by 2y plus 4. So that now that this is set up, I can go ahead and find the horizontal tangent and the vertical tangent. Since last time we started off with the vertical tangent, I figured this time we'll do the same thing. I'll put VT for vertical tangent. So remember, the vertical tangent means you set the denominator equal to 0, and that's going to be 2y plus 4 equal to 0. Solve for y, and you have y equals a negative 2. So what you're going to do with this negative 2 is that you're going to go ahead and take this and plug it back into the original equation. And remember, this is the original equation right here. So then I'll have 4x squared plus negative 2 squared minus 8x plus 4 times negative 2 plus 4 equals 0. Your goal now is to simplify this, and when you do simplify this, you will have, well, you will have like 4x squared plus 4 minus 8x minus 8 plus 4 equals 0. And as you can see, the simple numbers like 4, negative 8, and positive 4 all cancels out. And what remains is going to be 4x squared minus 8x equals 0. So now you're going to go ahead and solve for x. So when you're solving for x, we're going to have a 4x factored out. X minus 2 equals 0. So x equals 0 and positive 2. So to find your vertical tangents, you want to figure out when x is 0, what is y? When x is 2, what is y? And when you plug in the 2 and the 0 back into the original equation, you should have a negative 2 for the y and then a negative 2 for the y when x is 2 as well. So those are your vertical tangents. Now that I did that, let's go ahead and find the horizontal tangents. Horizontal tangent means you take the denominator, or excuse me, the numerator and set it equal to 0. So that's 8 minus 8x equal to 0. You're going to go ahead and solve for x. So negative 8x equals negative 8. X equals a positive 1. Now that you have x equals 1, you're going to plug it back into the original equation. So that would mean you will have a 4 times 1 squared plus y squared minus 8 times 1 plus 4y plus 4 equals 0. And your goal right now is to solve for y. So I have a 4 plus y squared minus 8 plus 4y plus 4 equals 0. And as you can see, the negative 8 and the positive 4 cancels. So what you have left behind is just a y squared and a 4y equals 0. I can factor out the y, so I have a y plus 4 inside the parenthesis equal to 0. And then I'll have y equal to 0 and y equals negative 4. So those are my two values of y. So then what you're going to do with that is you're going to take those numbers and you are going to ask yourself, okay, so here's my horizontal tangent. What is my x value when y equals 0? What is my x value when y equals negative 4? And if you plug that back into the original equation, you will be able to find that your x is going to be 1 when y equals 0. And for this one, you go ahead and give that a try. And these are going to be my two answers. All right, you guys. So for the remaining part of the day, I want you guys to go ahead and practice these 8 questions for the dead or alive game, even though you're at home. But practice with some of these questions. I think number 1 is really easy. So if you want to skip that, that's totally fine. But maybe try 2, 3, 4, 5, 6, 7. We actually went over in the warm up. 8 was also part of the AIM warm up. So maybe just try some of these questions and give it a whirl and see where you end up with. And then when you're done, go ahead and get started with the calculus puzzle. All right, you guys, I hope you guys have a wonderful day. And as always, stay safe and healthy. Take care.